Welcome to this explainer. Today, we're jumping straight into the invisible but highly structured world of ASHRAE standards. These are the rules that govern the safety, comfort, and sustainability of literally all our indoor spaces. Every single time you step into an office, a hospital, or a classroom, there's this massive, meticulously designed framework operating behind the scenes just to keep you breathing easy. So today, we're going to decode exactly how the whole shebang works. We usually only notice the HVAC when it's acting up, right? Like when you're freezing your way through a summer day in the office during those classic thermostat wars, or when the air just feels super stale. But the reality is, creating that perfect, unnoticeable indoor environment is an incredibly complex science. We spend so much of our lives indoors, yet we rarely think about the precise engineering required to maintain that flawless balance of fresh air and thermal comfort. Well, that precise engineering is guided by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE. They're a global technical authority with over 50,000 members spread across more than 130 countries. We're talking about a massive network of architects, mechanical contractors, building owners, and equipment manufacturers who all collaborate to write the rules for how our indoor environments should actually operate. So, here's our roadmap for today's explainer. We're going to look at the invisible architects themselves, break down the big three standards, dive into safety and health tech, flip through the industry handbook, and finally, reach the green building pinnacle. All right, let's start with part one, the invisible architects. ASHRAE is a consensus-driven body, and their standards act as the backbone for building codes and consulting engineers all over the globe. They really are the invisible architects defining our indoor reality. And rather than just setting arbitrary rules, they rely on years of rigorous research to publish these alphanumeric standards that dictate everything from energy efficiency to exactly how much fresh air is required to keep us healthy. Their core mission is literally advancing HVAC&R to serve humanity and promote a sustainable world. Plus, because our tech and our climate are always changing, these guidelines are on a continuous maintenance cycle, meaning they're periodically reviewed, revised, and republished to keep up. Moving right along to part two, the big three standards. If you're an HVAC designer, you know these three by heart. They form the absolute foundation of basic building design. These three standards work together continuously to ensure a building isn't just energy efficient, but actually habitable and comfortable for the human beings inside. And you really can't have one without the others. Think about it. If you seal up a building perfectly for energy efficiency under standard 90.1, but you completely fail to bring in fresh air under 62.1, you haven't built a great building. You've just created a highly efficient, miserable box. Let's break down standard 55 first. Now, comfort is super subjective, right? What's warm to you might be freezing to me. But by using a metric called the predicted mean vote, or PMV, designers can actually quantify it. PMV gives them a controllable framework that takes into account personal factors that an engineer can reasonably predict, like clothing insulation and metabolic rate. This means they can adjust the math depending on whether they're designing for a cozy space where people are sitting in heavy winter sweaters or a sunny, active office full of people walking around in t-shirts. Next up is Standard 62.1, which handles indoor air quality. First published way back in 1973 and continually updated through the energy crises all the way to today, this standard defines acceptable indoor air quality as air where 80% or more of occupants express zero dissatisfaction. To pull that off, designers can choose between two main paths. There's the simpler prescriptive ventilation rate procedure or the highly complex indoor air quality procedure, which requires a deep, performance-based analysis of specific contaminant sources and strengths in the space. When engineers go with that prescriptive ventilation rate procedure, they look at minimum ventilation rates to calculate the specific cubic feet per minute, or CFM, of outdoor air required per person and per square foot. Obviously, the fresh air demands for a densely packed lecture hall are mathematically going to be quite different from, say, a sprawling restaurant dining room. But what happens when things get a bit more complicated? Single zones are straightforward enough, but calculating ventilation for multiple zone systems requires a really meticulous three-step process. First, you determine the breathing zone rate. Second, you calculate the zone outdoor airflow by correcting for how effectively the air is actually distributed down to the occupants. And third, you determine the total outdoor air intake flow required for the entire system. It ensures that the fresh air actually reaches your lungs, rather than just getting trapped uselessly up near the ceiling. Rounding out the big three is Standard 90.1. This is the critical baseline utilized by building codes all across North America to dictate insulation thickness, lighting wattage, and HVAC equipment efficiency targets. This standard is incredibly vital right now, as it continuously pushes the envelope to drive our built environment toward net zero energy goals. It's honestly the main reason we're seeing smarter, highly efficient demand-controlled ventilation systems becoming the industry norm today.
Okay, let's look at part 3, safety, tech, and health. So once we've established comfort and efficiency, we have to look at how these complex machines are kept safe and smart. Modern buildings are intricate systems. This means applying standards 15 and 34 to safely classify and manage refrigerants so they don't pose a danger to anyone inside. It means utilizing standard 135, widely known as BACnet, to serve as the data communication protocol, literally the nervous system for building automation. And, highly relevant to our world today, it means implementing the groundbreaking new standard 241, which provides really rigorous guidelines for mitigating the risk of airborne infectious disease transmission.
Which brings us to part 4, the industry handbook. So how on earth do engineers actually access and apply this massive, highly technical catalog of ever-evolving codes on a daily basis? Well, they rely on the ASHRAE handbook and the Society's continuously updated online database. Available globally, these resources serve as the definitive Bible for HVACR professionals. Whether a designer is dealing with a super unique healthcare facility under Standard 170 or just looking for the latest addenda on thermal comfort, this database is where the invisible architects of our indoor world go to find the answers.
And finally, part 5, the green building pinnacle.
This is where we reach the absolute summit of our structure, where all these individual codes combine into a master blueprint for sustainability. Notice how Standard 189.1 literally stacks right on top of the foundation created by the Big Three, Standards 55, 62.1, and 90.1. Standard 189.1 is the authoritative standard for the design of high-performance green buildings. It doesn't replace the other codes at all. Instead, it adopts them, modifies them with much stricter targets, and builds upward. By adopting and enhancing the Big Three, Standard 189.1 pushes the entire industry towards its absolute highest potential. It essentially mandates the use of advanced technologies like energy recovery ventilation, or ERVs, to achieve a really difficult balance, bringing in vast amounts of fresh, healthy outdoor air while simultaneously slashing energy usage. It is the ultimate blueprint for creating the most sustainable, high-performance green buildings on the market today. Looking back at this massive architecture of codes and research, you really walk away with a profound appreciation for the meticulous engineering surrounding us every single day. We are never just sitting in a room. We are existing within a precisely calculated environment. And as we face down the massive climate and health challenges of tomorrow, it begs a really exciting question. How will these ever-evolving ASHRAE standards adapt next to further protect our planet and us? Thanks for exploring the building blocks of our environment with me in this explainer. Keep learning and stay curious.